Isn't that cool? Who cares about that? We're only concerned with the what?
The top.
Just the top. And we're almost gonna wrap this up here. It's just factoring. Cal, what can I factor out of that? Looks like we're getting two answers. Okay. There's gonna be two critical points here, everyone. What's one of them?
Zero.
That's one of them?
And
That's
two.
a CP, and the other one's x equal to?
Two.
There's two critical points. There's two critical points there, and you go, well, what about this? The reason we get to ignore it? Because it's just the asymptotes there.
I
Okay.
didn't realize that.
Yeah. So that makes you go, well, then golly, are we ever gonna, it's like you rarely have to deal with this. And you go, can you, and students always ask me, well, could you give me an example where this would come out? I always give students the function, the cube root of x, which is x to the 1/3. See, that function originally didn't have an asymptote, did it, Cal? But when you do its derivative, look what happens, everyone. You get 1/3 x to the negative 2/3, which makes it 1/3 over x to the 2/3. And where's this thing undefined? The first derivative is undefined at 0, but the original function, 0 is a point on the curve. Do you follow me? So this is one example where you could get a or D and E. At x equal to 0, there's a critical point here. That's good for discussion. You go, okay, here you get a critical point. Taylor, I wouldn't even worry about this here because you got the original function had this. That would mean it wouldn't exist there. Cool. And you want to do 37?
39.
Oh, 39, I keep doing the wrong one.
I'm so confused on why you're not doing anything with the bottom.
Do you remember with graphs like this? The original expression, I'm making up an easier one. At x equal to 2, wouldn't x equal to 2 make that original thing equal to 0? Josephine? Do you agree? 2 minus 2 makes that 0?
Yeah.
There would be an asymptote at 2 on the original function. No point would exist on that function, right? So since this was the original expression of the function, right? That means at any x value that makes this equal 0, at any x value that makes that equal 0, the function would not exist. The function would not exist. So to be a critical point, it has to be a point that does not exist that's on the original function. That's why. She probably still doesn't. Sorry. Can I read? All right, this is 39. Number 39, f of x equals x to the 4/5 times x minus 4 squared. Hey, what rule would we have to do? Product rule. Oh my God. That's a 4. No. Ellen, let's do it. Your n. M times n prime plus n times n prime. All right, x to the 4/5. All right, you get that one out with n prime. Now let's do x minus 4 squared. I say we do the chain rule. The 2 comes what?
2 times x minus
2
1
comes in front. Decrease this by 1
times 1.
times chain rule. What's the derivative of x minus 4?
1.
1. I'll write it, just so you know I applied chain rule. But I want to make sure, I don't want to rush on that. I've got x to the 4/5. For m prime, I've got 2 times x minus 4 to the first power times a 1. Chain rule. All right, what's the plus? Now you get x minus 4 squared. Oh man, what's m prime?
4/5.
4/5. X to the, everyone subtract a 1 from 4/5.
Negative 1/5.
Okay. So far so good? So let me write this again. You got 2x to the 4/5 times x minus 4 plus 4 times an x minus 4 squared 5, and guess where this is now? Down there, right? And I'm gonna figure out when this equals 0, so it does not exist. Okay. But I've got a fraction over here and I don't have this, so I would like to combine these. So how do I add fractions? I need common what? Denominators, good. So what I'm gonna do, since that has a 5x to the 1/5, and this is over just a 1, how about I multiply a 5x to the 1/5 here over a 5x to the 1/5 here. Now I can add these together, right? All right, let me write all this again. I've got one solo fraction, woohoo! But now I got, what's 5 times 2?
10.
10. All right, I gotta take this low. Who in here knows what x to the 1/5 times x to the 4/5 is? It's not x to the 4 over 25.
No, it's X.
It's just x. You add the powers. Oh, that was clean. And then you have this, just this simply what? X minus 4. Kel, so far so good? Oh, cool. And then we got the plus 4 x minus 4 squared. Oh boy, this is really pretty enough. Can you factor anything out of the top?
X minus 4.
You can factor out an x minus 4, anything else?
2.
Yeah. So you get x minus 4 and a 2. And what's left here?
5.
5x
plus
plus
2. X minus 4.
2 parentheses x minus 4.
Mm-hmm.
This is all of it is 5x to the 1/5 equals 0. Make sure that's there. Hey. Shh, it's only mine, even though it's on video. All right, everyone, combine all that stuff in the brackets. What do you get? 5x plus 2x minus 8.
Mm-hmm.
Man. Now this is interesting. And Josephine, I'm hoping this one helped make sense of what we were talking about before. It looks like we've got 3 critical points, everyone. Not 2. All right, first of all, what's an easy critical point?
4.
X equal to 4. Now what makes that equal 0? 8 sevenths or 7 eighths?
8 7.
8 sevenths, right? Yes, indeed. Here it is, Josephine. This time, I'm figuring out what makes x to the 1/5 times a 5 equals 0, which is simply x equals 0. Because that's what would make this first derivative non-existent. And you go, why can I include this time? And I didn't even look at it last time. It's because of the original function. The original function didn't have something sitting in the denominator like before. So this point right here, see 0? At 0, that 0 is on this graph. It exists. X equals 0 is in this domain. That's why I can include it. In the last problem, the original function had that denominator, had all that stuff there. So I ignored it. But now, I can use this. This is one of those rare cases. Does that make sense, Cal? Yeah? Oh, cool. Hey, that's what I mean, everyone. So I love this problem, just so everyone can finally make sense of this part here. I always have to include this. Critical point is where the first derivative is 0, where the first derivative does not exist. Well, this time I can include that value as a critical point, because the original function, that's a value that's on the function. 0 to the 4/5 times 0 minus 4 squared is 16. So that point, 0, 16 is on the function if it's a critical point. I like that. But they're rare. It's rare when you get to consider that, so I'm glad we did that one. All right, hey, I love all those questions. Everyone, we're going to start where we left off last. We were still in 4.4 with locus Cal's rule.
Professor, one more. On 4.3.
Yeah.
Can you go over number 32 and to make sure that we have the right answer?
Yeah, which one was that?
Number 32, the even one.
Even one, 32.
Yeah.
And, can I see him? I'm going to just check him.
Yeah, this one.
This is only take a I want to see your answers.
Oh, okay.
Because I was hoping the book would have the answers here, and it don't.
You don't see the answer.
Let's see, increases on 1 to 6. Is that a 1?
Oh, let me see, which, yeah, 1 and 6, yeah.
Oh, good.
Right.
Yep, that's right. Decreases 0 to 1.
Uh-huh,
6, 8, that's right.
okay, little max,
Yep. Then 1 and 8, yep.
okay.
Concave up, I love cup. 0 to 2, yep. 2 to 5, yep. 7 and 8, yep. And then 2 to 3. 2 to 3 went down. And then from 5 to 7, perfect.
Let's go.
Perfect, good
Okay.
job.
Thank you.
Everyone, I was checking his answer, thanks for being patient. On number 32, it's an even problem. I thought it's a great problem, but even answers aren't where?
In the book.
Bag of the book. So if anybody wanted to check it with me, you can either check with me, and I can tell you if you did it right, or I just checked Art's, he's got it too if you want to check with his. It's a good problem. It's the thing where you analyze F prime, and you try to figure out what's going on with F in terms of a graph. So, all right, everyone, this is where we're at. We're in Wallopi, right? Wallopi? It's spelled like El Hospital, looks like. Well, L'Hopital drool. It's used with indeterminate form with limits, true?
Mm-hmm.
If you get the infinity or 0 over 0, we did a bunch of problems, but I told you next class we're going to start with 3 more. Let's do a few more. Everyone, I'm in 4.4. I would like to start with number 35. The page number. Page 308. Okay. And when you gotta find this limit, so I'm gonna give you some time to work this. X approaches 1. They've got a 1. Oh, that's a minus X. Some of you may have already worked this. The reason I'm assigning this, or why I want to work this in class, I know you all know what the derivative of X is. It's that guy. I'm worried what you would do on a test with that scenario, or the final. Because one little slip up and the whole limit answer is wrong, right? We all know what to do with L'Hopital rule, check? We check to see, we substitute that number at the beginning. If we get 0 over 0, or infinity over infinity, or negative infinity over infinity, we just take the derivative of the top, derivative of the bottom, we do it again, right? Substitute it. Well, let's plug in 1. 1 minus 1,
0.
0. Element of 1 is 0, I get a 0. 1 plus cosine of pi. Cosine of pi is negative 1. Do you agree?
Yeah.
Mm-hmm.
So 1 plus negative 1 is,
0.
looks like I got indeterminate form, right?
Yeah.
I've got indeterminate form here. So, L'Hopital rule. What's the derivative of the top?
Minus 1 plus 1 over x.
Ooh, good job. Negative 1. That was 0, right on? And derivative. So far so good?
Mm-hmm.
This is what I'm worried about.
1 minus pi sine pi.
No,
want the
1 will be 0. So negative pi sine x times pi.
And what's the derivative of cosine pi x? We all know the derivative of the 1 is 0, right?
1 negative sine.
What's the derivative of cosine pi x? Is it just sine pi x?
No, no.
Is it
times,
just negative sine pi x?
times pi. Negative sine pi x times pi.
I love it. What?
Chain rule.
Chain rule. It comes up over and over and over. I mean, expected every day, right? We're like, the derivative, that's 1, but we're like, what's the derivative of cosine pi x? We know because of SCSCS, that derivative of cosine is a negative sine. So you're like, oh, negative sine, but I get this all the time. It
What
happens,
about the 1?
right? Oh, do you agree? What's the derivative of 1? It's a constant. Derivative of constant 0, right? Yeah, but it's here. And this is where the errors occur. You'll remember that. You'll know derivative of constant 0. It's here. That's not it. I have to multiply what?
Pi.
Then
pi.
why did you put
because of this guy. So let me write this became 0. You follow? Okay, but now, chain rule negative what? Pi sine of pi x. It's negative sine of pi x times g prime. Negative sine of pi x times a, what's the derivative of that pi x? Pi. Do you follow? But over and over and over, it just keeps getting us, right? The old chain rule. Let's plug 1 in. Oh my goodness.
Still
We're getting
0.
0 on top. And then when we're getting 0 again on the bottom. So what do we got to do?
Take the
Again,
derivative.
Go another round. Got another indeterminate form? Okay. That's a good one. Do another round. Well, good news, Amber. There are zeros. Yep, get constant. 0. Derivative -1, 0. Yeah, how do I do that derivative?
negative 1 over
Do you
x
want
to
to do
the,
quotient rule?
no, you can do x to the power minus
I
1.
love it. Can we look at that 1 over x like this?
Yeah, it'd
And
be
so we differentiate it, it'll be just
Negative.
just like that? Wouldn't that be its derivative? Everyone, let me write derivative here. D, derivative of all this, with respect to x, would just equal this. Which in other ways is negative 1 over what? Does someone see that? We didn't have to do quotient rule on that thing. You could have, but we're all like, let's do it that way. So that'll become, that's 0, minus 1 over x squared, limit as x goes to 1. And what's this derivative?
negative pi squared cosine of pi.
Great, this is a great discussion. I don't need product rule, do I?
No, no.
I don't, because that's not a variable, that's a constant, right? Do you agree? Yeah, I don't need product rule, I don't agree. I'll just keep that pi there,